Today I'll be speaking about mutational tests. And this is a great topic because I learned about it when I joined the Zenitech. And this testing was very interesting for me. So I'm not using it in our company, but also for that I'll make a presentation to you and show you the benefits. So let's begin. So today's agenda is, as you see here, it's about a short introduction about me. We'll shortly go through some basic knowledge just to have the same ground why testing is needed at all, about testing pyramid. Then we'll discuss very widely used measurement of test suite with test coverage. And after that, we'll have some coding session, as Rimva just mentioned. We'll see how it's done in the code. I'll show you the examples. I'll run some tests, and all the code will be available in a repository that organizers will share with you. Then, as you might guess, surprise, surprise, we'll talk about mutational testing. I'll explain mutator examples. I'll show you the examples and explain how those mutational testing steps are created and executed. And I'll discuss testing tools that are used to execute those mutational tests. And we'll have also a second coding session regarding the mutational tests. So you will be also able to see with your own eyes how it's done, what are the results, what are the benefits, and how is it executed. And last but not least, there will be some discussion regarding mutational test cost and optimization. I'll talk about mutational testing cost because you gain something, you lose something. So it's, I think, very important to know the benefits and to decide where and how to use them. So let's go. Shortly about me, I have experience of parenting for already more than 5 months. You see my son here in the picture. Very lovely boy. I'm coding with Java for more than 10 years. And I'm working in Zenitech for 1 year and 3 months, I think, right now. And I worked on legacy projects, on greenfield projects, and I very much love to share ideas and knowledge because not only I introduce some topics to other people, but also I learn myself thoroughly the topic, because if I cannot understand the topic, I cannot present it well. So it's a win-win situation. And I encourage you to also participate in meetups and to do presentations. This is very awesome, as I said, for presenter and for listeners. So why testing is needed at all? So you can see the picture of this happy kid that refactored the code that he wrote by himself months ago and actually had unit tests. So he is strongly confident if his tests are green, that he didn't break something or introduce some regression in the code base. So tests, of course, when you write tests, it takes time, but it takes time, the same amount of time every time when you introduce the new feature. And it slows down you a little bit in the beginning because you have to do double work. You write code, you write tests, or vice versa if you go test-driven development. But it goes together. And after some time, if you have tests, you have this steady pace how you deliver new features. And not only that, also you have confidence that you will not break something that you already created. And our customers, your clients, stay happy. And of course, you stay happy as a developer because you don't have to, in a rush, fix those bugs and have stressful situations. So there are lots of benefits. And one more benefit is to have tests as documentation, because it's a living documentation, and if you change your code, you definitely have to change your tests, because if you will not change your tests, simply your build will not be completing successfully, and you'll not be able to forget to update your documentation. In this case, I mean your tests, they serve as a primary documentation. And for example, if you have tests somewhere else, like in Confluence page or in some shared Google Doc, so I've seen lots of times that people just forget or are too lazy to update the documentation, and they start to diverge from each other. So the code lives one life and your documentation lives another. And reading from documentation, you see that actually code does something else. So I think it's better not to have documentation at all when it is in this situation. And having tests, you just open the tests, and if tests are written correctly, you can learn a lot about the system only by looking at the tests and trying to execute them. And of course, when somebody else joins, for example, our company or our team, they can go straight to the tests and onboard faster, because they can understand how the system is working. They can try to run those tests. They can amend those tests and try to play with the system. And of course, it's business crucial to have tested software that we ship to production, because if we lose our clients and they saw, for example, that this irritating bug was happening, they'll probably not be coming back. And for example, now what's happening with Cyberpunk, when they released software and people say, okay, this is not working, and they're very disappointed. So going to the next slide, we have a testing pyramid. It resembles us Maslow pyramid, and you see that going straight to the top, we have less and less and less space for the tests. What does it mean? It means that the biggest part of our test suite should be comprised of unit tests, and it is in the bottom of the pyramid. And going up, we have component, integration, systems, and manual tests. So unit tests, they're very isolated, and you can very quickly see when your test fails, what is the reason why that test failed, and you can very quickly fix the issue. Going up, you have component tests that test multiple units, how they work together. For example, if in object-oriented languages, it will be a module that is comprised of multiple classes or objects working together. And going up, you have integration tests. So you test how those components or your system integrates with another systems. And system tests, they are tests when you run all your application. For example, if you have a web application, so you spin up a web server, you have actually working system, and you run tests to check if your system is working as you expect. And of course, sometimes it's not so feasible and very tedious and very complicated to automate everything. So it's usually said that there should be some space for manual tests that could be executed manually by hand, for example, with QA engineer help, or a developer can do that, and we still have those on the top. So now, if we know that our tests are very valuable and we see that we need them, there are some standards and ways how to say that, how to measure if our tests test suite is written well, and if we're actually testing enough in our system, and do we have confidence or do we not? So there are different types of test coverage. In a broad sense, it means that when we have our system, our actual application, and we run tests, so test coverage checks if our tests actually execute some parts of our system. And those parts can be defined in different types. So, for example, the first one, as you see, is statement or line coverage. It's very easy to grasp and understand. So you have running application, and you run your test. So if that test hits the line in your code, then we say that line is covered. Functional or method coverage, it's also very easy to grasp. It just checks if our function or method was invoked at least once when we run our test suite. Decision coverage, it's like while or if statements. Condition coverage, if all our conditions, if multiple conditions comprise our if statement, so we check if all conditions are checked. And branch coverage, it's related to system control flow. And the industry de facto standard is the last one, and it's usually said that it's very good, and we can say that we are confident if we have at least 80% of branch coverage. And sometimes crazy people say, okay, let's go for 100, but it's only looking good like a number, or like doing a report, or presenting to a company. But from development perspective, it's usually duplicated work, and usually when you have 80% coverage, so going up to 100 will just give you more tests that actually test the same thing. So 8% is industry standard. So as I said, now will be the first coding session. I'll show you the domain logic of application that was created when I did my first presentation in Automate IT. So I just extended the same project, so you can see that there are another modules. But in a short description, I can say that this project is multi-module Maven project, and we have different modules for different presentation topics. So today's presentation is mutational testing, and it depends on core. So core module defines our domain, and our domain is actually very simple. So let me show that. We have a domain object that is artist, and artist has a name. It has the genre, what music he plays or she plays, and the set of albums that was released by this artist. And the album, it's also very not complex object. It has album name, it has the release date, and it has, of course, the list of songs. So this is only the list of the names, song names, and we have list because we care about the order of our songs. And artist factory, this is a simple factory, the design pattern, how to create an artist. So I'll be using this one factory method, create artist, when I'll pass the artist name, the genre, month when that album was released, and how many albums were released. So this is the domain, very simple. And now if we go to testing, first of all, to show you how the testing is done and how to see the test coverage. So I prepared the artist service. So this artist service, it has one method that checks if artist has released at least album in the autumn. So what does it mean? We check if artist has albums at all, if albums are not empty, and we check if any of those albums has a release month that is higher or equal to September or less than equal to November. So to check if it's released in autumn. So going to today's topic and discussing now test coverage. So we can check that IntelliJ can also show us test coverage. So for example, if I run this test now, and while it is running, I'll comment what it is the test is doing. So we have this given when then description of the tests. So given one album released in August, you see I create album in August. Okay, let me show you. It's released in August. We release one album, genre it's minimal, and artist, this is only the name of the artist, it's Awesome John. So John released that in August because he had time, he was on quarantine and was sitting at home. He likes to play minimal, so he said, okay, let's release the album. So he did release the album in August. So what we're checking here, we're checking that artist service has album released in autumn, and because our month is August, we expect that this is false. And our test it passes. We see the green light, and we see IntelliJ it has this functionality to show us the test coverage. So if we go to artist service, you can see that method and line coverage, it's 100%. And it's really cool. We say, yeah, we achieved that 100. And going to artist service, we see green tabs here that everything is fine. But if, for example, I change month from September to, for example, October, and I introduced the bug, because as we know all that autumn is from September to November, I created now from October to November. So our test, you may already guess, it still be green. So there should be another way how to test it and how to know if everything is fine. So for that, in Java, there is the de facto standard that's called Jacoco. It's explained as Java code coverage. So I have this tool set up here, and I'll also show you how it's working. So I'll just return again to correct functionality that autumn is from September to November. And I'll have my test. Now I would like to show you Jacoco configuration. So Jacoco is defined in POM XML. It's in parent POM, where we have our plugin management section. And we can define here rules, what we would like to check with Jacoco. Jacoco is simply Java virtual machine agent that checks what instructions are executed, and by that it gives us a nice report. So that report could be integrated to Sonar Cube, or we can check the results in our IntelliJ, what I'll do in a short period of time. So we have Jacoco Maven plugin, we have our test, and if I run Maven, you will be able to see the result of Jacoco. So let's wait a little. Now what I'm doing, I'm selecting a Mutational Tests module and running test lifecycle phase to execute our test. The same that we've done with IntelliJ code coverage. Yes, now we see we have errors. So if we go here and see what is happening, so we see that our artist service has branches coverage ratio only 0.37, but expected minimum is 0.8. So if we want to check, this is the file that is created by Jacoco, but to see the actual results, it's way better to generate report. So I can run Jacoco plugin and say, okay, please give me the report. This report is generated all the time in target directory if everything is fine. But in this case, because it was broken, so no report was generated. You see now that site emerged. We have Jacoco, and if I open the index HTML with my default browser, so you can see that we have missed instructions and missed branches, and coverage only is 47%. So we can go inside. Let me make it bigger for you to see what's happening. So we now see that in Jacoco we have green, yellow, and red lines and branches covered. So green means that everything is covered. Red means that this was not executed at all. This line, branch, or another coverage. In this example, this is the branch, and yellow says that only some parts were executed. So if I go here, I can see that only one branch of 2 was executed and 1 is missing. So what I could forget, yes, I didn't check if albums are empty, because I always create one album released in August. So this branch will also need to be covered. And this one is also only one branch is covered, because I checked only when it don't match. And I would need to check more branches. You can see here that 3 branches of 4 are missed, and we checked only the August, that is before the September. So we also have to check what happened before September, in the autumn, and after the autumn. So, okay, let's go back to our artist test after service test, and let's create those tests that we are actually need. Okay, so as I said, we have to check the branch when no albums are released at all. So for example, I create the test when in January we released 0 albums. So I'll rename here. So I say given 0 albums released in January, when checking if ever released in autumn, then return false. Correct. The second one, I would like to check in August, the one that was released in August, and August is before September, so it's also false. Now we'll check one in October that is actually in the autumn. So let me just remove the test. Should return here. We have to get true. So you'll also amend assertion. And last but not least, we also have to check after the autumn. And after the autumn, it should also be false. So I'll rename my test name December. So let's double check. We have in January 0 false. We have in August 1 false. It's not in autumn. October 1 true. December 1 false. Okay, let's check now what Jacopa shows us and what are now the results of our branch coverage. If we are lucky enough, we'll be able to see that everything is fine, and probably our test is actually checking all the conditions, and we can safely say to our client that yes, everything is working and we're good to go. So we are running our tests. Okay, we see that build now is successful. So we covered, we know for sure that we covered at least 80% of our branching testing. But if we go to report, we see, voila, we see everything is covered. Great. So this is the factor interest standard to check the branch coverage. And for my example, as you see from my example, that now we can say that our tests are actually doing what they were expected to be doing. So now going back to presentation, I would like to ask you a question. So what do you think when we now have this test branch coverage and line coverage equal to 100%? Can we say for sure that our test suite is actually doing what it's expected to do, and we can safely go to do Cuba Libre and see some movie and relax? It's very hard because I don't see your faces. So I would like to comment maybe this time on the picture in the bottom. So it implies that if our test coverage is good, that our feature is implemented well, and if our coverage is poor, so we cannot say for sure if everything is working well. So the answer to this question is actually 100% of code coverage, and in our example, the branch coverage only means as I discussed previously, that some parts of our program were executed at least once. So lines were hitted, methods were called, or branches were executed in one or another test case. But it actually doesn't say anything. Okay, I cannot say anything, but it doesn't tell us 100% that our test suite is actually testing what is expected to be tested. And to actually check if our tests are good, we have mutational tests. And when I joined Zenitech, it was really eyes opener for me because in Zenitech we do lots of mutational testing, and it's really, really very beneficial if you know how to use it. So you can only say that your test actually tests what it's needed to be tested only when you change your actual program code and at least one of your tests fails. Because think about that for a second. If you change something in your code and all your tests are green, for example, for sure you can guess that your tests are not testing all the cases. So, as I said already, mutational testing, it's deliberate injection of faults, or as we say, mutations, into the software system, and then verifying if at least one test fails. And if your tests fail, at least one fails, we say that mutant is spotted. Usually frameworks call mutations are killed or mutants are killed, because I like X-Men, I say they are spotted. So when we mutate our code and at least one test fails, we say that mutation is spotted, and we say that our test our test actually tests the corner cases. To understand better how it's done and what actual are the mutations in code, I'll show you shortly the examples how your code might be mutated and how the tests spot those mutants. And one more code coverage for your tests would be how many mutants were created and how many mutants were spotted. So you divide spotted mutants by mutants created. If you spot all the mutants, then you say that your mutational test coverage is 100%. And this is really good number. So mutational steps and the process, it's a very simple one for you to understand how it's done in a broad way. Different frameworks do it slightly different, and there are reasons for that. I'll just very shortly, in the end of the presentation, will present to you them. But in a very clear way, and to be able to understand what's happening, we have this mutational test steps. So first of all, we have our software system created, and we have test suite. So we inject the mutant, we change something in our software system, and then we execute our test suite and check if at least one of our tests is failing. We say that mutant is spotted, and if we introduce the bug in our software, our tests actually will find it, because when we mutate, we actually are creating some functionality or behavior of the system that was not expected when it was created. And we repeat that procedure multiple times for every mutants that we create. So you might be guessing what are those mutations and how they are done. So this is these are 3 examples how it's done. And the first example is, for example, conditional boundary change. So you should look from the left to right. So you see that A, first condition, if A is less than B, do something. So mutational testing would take that part of the code, actual code, not the test code, but actual code, and will change the if statement. As you see, it will do, for example, A is not only less, but also equal to B, and then do something. And run your tests for mutator, as you see in the right side. So one of your tests, it should be able to spot the situation. If not, you were not covering all the edge cases. Another example is negate conditionals. For example, when you check A is equal to B and you change to A is not equal to B. And others can be, for example, you simply don't execute the code, you don't call the method, as you see in the last example, just invocation to some void method is just simply deleted. There are lots of mutator types, and in my example that I will be showing, I'm using the generic bundle of mutators, but it's very usual to see that you can select what mutators you need and explicitly define what mutators you want to be executed. So the coding session number 2, let's go back to our code. And we had Jacoco that showed us 100% of our branch coverage. And here I have, now we are in mutation testing module. And in that module, I have defined the p-test. This is the de facto standard in Java to run mutational tests. So I'll just mark to skip the test false. So what it will do, it will actually execute on Maven phase test also the mutational coverage. And my mutational coverage, I defined that I want to have mutational threshold 100%. So once again, let's run those tests and to see what we see with mutational testing example, hands-on. So now it's happening the same as it was happening. Our tests are executed, our Jacoco report is created, but additionally we create mutants. You will see that in red color in terminal. Here we go. We have mutants created, and we execute now our test suite for those mutants. And now we have failure. And if we check, we see that we only have mutational score of 82% instead of 100. And now if you are interested, how does it look? We have a report for that. So this plugin, p-test Maven plugin, it generates in target folder pit reports folder. You can find the index file, and if you open that file, you will see now mutational test coverage report. So we see still that our line coverage is 100%, but mutational coverage is only 9 of 11. If we go inside and check our artist service, now we have red color. So you see in the bottom, we have the mutators defined, and yeah, they call it mutator killed. I say it's spotted. So if it's green, you say that mutation was spotted by a test. So everything is good in 11 and 12 lines. So for example, we see that Boolean return simply with true, and our test was able to spot it, and we negated conditional, and it was also killed. But if we go to line 17, we see that 2 survived. So 2 survived that were that had conditional boundary changed. Okay, so this gives us more insights to our test suite coverage, and if actually our 2 test suites are written in good way. So to fix that, I once again go to our test file, and you see, because we tested only August, December, and October, we didn't check the test boundaries, and they are actually September and November. So, for example, if we once again introduce the bug and change from November to October, so this test, the checks in October, it will pass. And mutational tests, they showed us that we didn't manage to cover the boundaries. So if I now fix my test, because I know that from the mutational report, I would say, okay, now I'm smarter, so I can do from September to November. I'll also rename the names, because I care about my colleagues. If they read this test, they should be able to see the same names that actually the thing is tested, and the name is actually shows what things are tested. And let me double check. Yes, right. In September, we released 1 album, Assert True. And in November, we released another album. Oh, we like that minimal. We released another album, and we have also True. So once again, let's run mutational test. And we'll see what we have. You see now that everything is starting as in the previous examples. And you might already saw that executing mutational tests, it takes a little bit longer. That's because we simply run our test as we do every time with JUnit or another platform. How you run your test, for example, test engine, and with mutational testing, you execute additional steps to create those mutants and to run your tests. So voila, you now see that everything is green. And if I go to PIT report, I'll open it in my default browser. Voila, now I have flying coverage and mutational coverage 100%. And that's why, that's because I covered the conditionals. Now, September and November, they are actually checked in my tests. So if, for example, somebody writes instead of September, October, no, the test suite will check that and say this is an error. All right, so to wrap up, now going to like second part of the presentation that will be, of course, short, like 10 minutes, but I wanted to give you the broad explanation, what are the tools in Java world to play with mutational testing, because there is not only one tool, and I'll also discuss what are the benefits and and drawbacks when you use mutational tests, because every time in life, this is a balance. You get something, you lose something. So mutational test tools, we know what we checked and what you'll be able to see if you check out repository. As Rimvidas mentioned, there will be this plugin and engine defined, so you can straight start to play with that mutational testing and write your own tests or take that configuration to your project. And this is de facto standard in JVM world, in Java world, how to do mutational testing. This is the tool that we use in Zenitech, and this is a very powerful tool because you can tweak it as you want. You can define different mutators, how to execute them sequentially or in parallel, and so on. And for p-test, there is also created p-test for multi-module project. It's used in multi-module projects, and for example, now we have our service and test defined in the same module. But for example, if you have multiple modules project and you want to run your test in one module, but mutate the actual software classes from another module, you can use this plugin, PIT-MP. Then going down, we have Java Launch. It's a mutational framework to have special focus on automation and efficiency of mutations, how they are created, how fast they are created, how fast they are executed, and so on. So this one would give you speed, but to start using, I would better recommend to start from p-test, because all other frameworks, there are not so many documentation about them, and you will need to tweak that system by yourself a lot. Next, we have Little Darwin. It's mutational testing created specifically to complex Java software systems. So if you have that one, you can read about that in literature that I shared with you. I guess the organizers will be able to somehow share the literature about this. And I found very good article where if you would like to try and set up, you can start reading that. Next, we have new unit. It's a mutational analysis framework for OCGI services. So if you have OCGI Java application, then this one would probably give you more abilities to execute your tests. And one more is JMint. It's also for integration test suite. Pipelines and integration. So if you have not only unit tests but integration tests, then you can also check this one. Now, regarding the costs of mutational testing. So you can see in the right corner, this is the example, the picture that I would like to explain you. So sometimes it's possible that when we mutate our code, our results from the output of method call or some function call might be the same, and nothing will be changed, and our tests will not be able to spot the difference. So this is called equivalent mutants. And for example, you have to look here from top to bottom. You should look prods1 and prods1 in the bottom. So the one in the top, it's original code, and the one in the bottom, it's mutated code. So for example, if we see the left side from top to bottom, we see that we mutated that I increment by 1, we mutate it with decreasing by 1. And because the starting position of I is 0, it's very crucial on return value, because if it's higher than 0, we return the same input number. If it's equal or less, we return negated. So if we had 0 and increased by 1, we have 1 more than 0, we will always get input number that it's the same as we passed to our method. And when we mutate it, starting from 0, mutate, and as you see with red arrow, now we have decreased by 1. We will always get input number that is negated. So this is the situation that it's good for us, and it's good for mutational testing. And this is the thing that when you can see the different return value from your method. And now talking about equivalent mutants, the one that I said that it's one of the key factors why mutational testing it's not used broadly and can give you false positives. Let's say you have, as we have in another example now in the right side, you should also look from top to bottom. You have prods 2 and prods 2 on the bottom. So because now we start from I equal to 2 and we increment by 1, we will always get the same number. But if we start from 2 and decrease by 1, we will still have a positive number, and 2 minus 1 will be more than 0. So in both cases, we'll have the same return values from our method, and our tests will not be able to spot the mutation. So for that reason, good practice is set to see those happening in your code. And if you have, if you run your mutational testing and you see that your test fails, you can go and see that actual mutation is equivalent mutant, and you can simply discard that mutant from configuration of your mutational engine. So this is the de facto how it is done in industry. And of course, when we execute, first of all, we mutate our code and produce those mutants, and then we once again execute tests for all those cases of mutations. So it takes really significant time to run, and this is another cost why people are not running those tests a lot in the laptops, in their machines, and in the pipelines. So from my point of view, and in Zemitech, we have those running in pipelines all the time. And in your machine, you can simply have Maven profiles that don't execute the mutational tests, and you can trigger them manually by executing a specific Maven profile. So there are, of course, test optimizations. So you can say that, okay, I don't need this whole suite of mutators, and I can select some parts. So there are some optimizations, but be careful, because when you give away something, you also lose something. So you will not be able to say that, okay, my test suite is actually doing what I expected, and be very sure about that. You are saying, okay, this is good enough. So you can have incremental analysis. So your mutational engine can save runs from previous mutational testing and apply those when you rerun your tests. So if, for example, it sees that code was not changed at all, it might ignore running those. So this applies to incremental analysis. You can have mutant sampling. This is selection of subset of all your mutants. You can have selective mutation when you reduce the number of mutations applied, and you can have weak mutation. It's very similar to strong mutation, but it doesn't actually run your tests. What it does, it mutates your code. it checks what inputs are coming from your tests, and when the engine runs those inputs, passes those inputs to your program, it just verifies if something was changed. For example, the program state was changed or return value was changed. And the engine doesn't run your test at all. It just says, okay, if something was changed, I can be sure that some test will be covering that case. So this is no way equal to strong mutation. This is optimization, and be careful when you use those optimizations in your pipeline and in your project. And last slide before the question session, it's always said that it's very, very crucial to define the optimal setup, to decide what functions you need, where you can say, okay, this is maybe not so beneficial in my project, and I'll skip that. So what optimal setup I can have? I can limit a set of mutators, as we saw. I can say only please apply these mutators and skip other. I can limit the target classes that are actually mutated. I can limit the number of my tests that are run after my target classes are mutated. I can limit the dependency distance. Does it mean that I can say, for example, if dependency distance is 1, then please only check the mutations that my tests call in one step. For example, in example that I gave you, we had the service and service test. So service test actually calls the service. And for example, if we would set up dependency distance 2, 3, or more, then we will check. We will check also the mutations if our service calls another service. So we can modify first service and second service, third service. So you can always skip, for example, say, okay, I don't want any more services to be mutated, only the first one. So my dependency distance would be 1. If our test could be run, of course, we can run them simultaneously in parallel. We can apply incremental analysis. And there is also a very good feature that is also broadly used, that you can only check and mutate those classes that were actually modified. And for that reason, you can use version control systems like Git or others, and your engine will be able to check if code was changed, then only try to mutate and run your tests. Yes, so that's it from my side and what I wanted to show you today. Hope you got some things to search and to check the mutational testing. And as I said, for me, it was really a very interesting tool that I saw in Zenitech, and I encourage you to also investigate and start using. Thank you.
Thank you, Arunas, for such an impressive presentation on mutation tests with Java. We got a few questions, so let's jump to the first one. It's by Justas. How long it takes to run mutation testing at unit test level for a big real live project?
For example, in project that I'm actually working right now, we have our build with all the tests without the mutational. It builds in somewhere around 1 minute, and with mutational we have build running from 2.5 to 3 minutes, so something like that. But we are applying all the mutators. We're not skipping and doing all the checks.
Thank you for your answer. The next one is from Regimantas. How to identify what set of mutations should be selected? What are the main criteria?
Very good question. So first of all, as I said, you should be checking the mutators in those cases when you have equivalent mutants. So that's for sure when you would like to somehow define what mutators to apply. Usually, those bundles created, they're optimized. So there are, for example, in p-test, there are multiple bundles. So I think 4 or 5. So I didn't see actually when those bundles would not be used, but you manually would define the mutators. But definitely see lots of mutators skipped when they create equal mutants. And if you have lots of equal mutants created in your code, from experience, I can say that it's usually a sign that you would have to refactor your code and to be able to have smaller functions that return some value or do one thing. Because if you have very big method and lots of things are happening there inside, then the result might not be changed, and you would have this equal mutants. But if you have coarse-grained, very small methods, and they do one thing and return some value, you can eliminate those equal mutants and still use the bundles.
Thank you, Arunas. And the last one from Justas again. What about mutation testing at system level tests? Would it be feasible to run mutation tests for test suite that includes end-to-end tests?
Mutational tests, they are created more for unit tests. And for system or integration tests, there are initiatives how to do that, but it's very hard to determine that when you change something in one part of the system, it would manifest itself in another when you have these integration tests. And because of that, and because of the thing that when you have integration tests, you usually not writing some tests that do nothing. You're actually checking if all your components together work as expected. So mutational testing, it's not so valuable in that sense. So for integration tests, we don't use that. As I said, I read that there are initiatives, but very questionable. Now, regarding the tests run times, it's also a very good question. I would like to see the times to run those tests because more components have to be started. And yeah, we should focus mutational on unit tests. This is what de facto standards and people how use them are suggesting.